For those who are not here in class on Tuesday, I went over the science lesson with the rest of the class. So here is a brief video on lesson 12.3, how do forces affect motion. So we looked into the first part where we talked about force. One thing to note is that I actually made some changes from the first day's notes. So, and because I wanted you guys to try fixing and changing things in your notes, I purposely gave you a different equation. Okay, so you wrote it down, but the equation was wrong. So what I asked your classmates to do was to erase the parts that you had, the example, the equation, and wrote down N equals mass times rate, which is N is a force equals mass times rate, or acceleration. And I put mass is 1 kilogram in this case, and then the acceleration or the rate is 4 meters per second squared, and I just multiply them and get 4N. N as the unit of force, Newton. Okay, so I indicated changes were made here, so I needed to put that in your notes just so that you can have an accurate information. Okay, I'm not going to go over the ones that we did previously. I did ask the rest of the class to review balanced force and unbalanced force. So if you want to go ahead and underline it or highlight some of these keywords, you may go ahead and do so. One thing we started from, and as you see, I have the dates indicated on the side corner. Sometimes it's helpful to keep track of the days that we worked on it. It's optional, but I strongly recommend you to do so. Contact and non-contact forces are very simple in terms of the vocabulary, because if it's contact forces, you have to be connected in order to have the force applied. If it's non-contact forces, you don't have to physically attach to something in order to exert force onto something. So contact forces, for example, pulling on the rope. If you are doing a game of tug of war, you are going to pull on your ropes. And that's going to be contact forces because your hands and the rope is going to be contacted. You're going to have a part of your body connected to the other object. Or pulling a trolley or pushing something. So as long as you're actually touching the object that you are putting your force on, that's going to be considered contact forces. For non-contact forces, however, you have 3 different non-contact forces. The first one is magnetic force. So this is something that you can find out with compass or your magnets. And what happens is that whenever you have a compass and you're trying to find which way is north, which way is south, your compass needle is going to go around. And even though you can't see the Earth's magnetism, you are going to see how that force is moving the compass needles and having some sort of influence. So we talk about Earth magnetism, compass needles are going to move. And the static electricity is also another one. So the easiest way to think about it is when you rub your hair against a balloon, your hair is going to float and it's going to make crazy hair. And that's a great example of static electricity. Or just touching your pet on a very dry day, you may get shocked on your hands or on the cat or maybe on the doorknob, or wearing a sweater and having static reaction. So you can have a lot of different happenings that relates to static electricity. Last but not least, gravity. We are all familiar with it because if we don't have gravity, we would not be standing or sitting or sleeping or just alive in general. It's a force that attracts each other due to their masses. So the bigger the mass is, the greater the gravity force you're going to have. And because Earth, where we live, has the greatest mass for us, we are attached to the surface of the Earth. And we also have things such as atmosphere because, again, gravity is holding onto all these air molecules so it's not flying away out to the space. If we don't have gravity, we won't have atmosphere and we won't be able to breathe. So it is also very important. So all three of these forces are going to be important because they do not have to touch you. Now you may say, but Ms. Pak, gravity is kind of touching us because aren't we all attached to the ground? But the thing is, even if you drop a pencil or a pen or something from the sky, you are going to still see those things moving and falling toward the center of the earth. So it's not going to be attached in the first place, but you still see the force exerted upon other objects. The other ones that we're going to talk about is the laws of motion. And Newton proposed 3 different laws of motion. The first one is law of inertia. You probably have heard of it before. Inertia means all objects have a tendency to resist any change in motion. So if an object is still, is at rest, that's what it means to be still, then they probably want to just stay in the position that they were at. Unless someone or something start putting some sort of force to move it to a different position. Or an object that is in motion, for example, a ball or a car, a wheel, something that's in motion will want to stay in motion unless they have another force. So for example, if you roll a bowling ball on an alley, it's going to roll until the gravity and also friction exerts upon the ball and kind of stops the ball after a certain while. But in theory, if they don't have any friction or other force that's stopping that motion, it's going to continue. The second law of motion is law of acceleration. Now, acceleration depends on 2 things. First, mass. Second, the force applied to the mass. So let's say we have an object. Acceleration of that object will depend on how big or heavy the object is, and also how much energy or force you're putting upon that object. So we have 2 different equations that you'll have to know. First one is force equals mass times acceleration. If you recall, slightly above, right, N is force. Right? Force equals mass times rate. Rate is actually acceleration, same thing. So you're going to see mass times acceleration and you will be able to find out the force of it. In order to find acceleration, you'll have to think of this as math equations in a sense. Because if you notice from this equation, if you want to leave acceleration by itself, you would want to undo or do the reverse operation. Right now, they were doing mass times acceleration. So in order to undo it or do the inverse operation, you would want to divide the mass. So you divide both sides by mass and you get rid of the mass on the right side. And you are left with acceleration, which is going to be by itself, equals force divided by mass. So we're going to practice a couple of questions. For example, let's suppose a loaded grocery cart had a mass of 50 kilograms. The reason why I'm using kilograms instead of pounds is because their unit is going to be with meter per second squared. Everything is metric system, so we go with the metric system. What is needed to give the cart an acceleration of 0.2 meters per second squared south? So let's say I'm pushing something to south direction, and I need to find out the force. How much of it would I need? So first thing, I have the force, and I have to have the mass, which is going to be 50 kilogram in this case. And then they give you the acceleration of 0.2 meter per second. So all I have to do is to multiply two numbers. And if I do 50 times 0.2, it gives me 10. So my final answer is going to be 10 Newton. I need 10 Newton to push something with an acceleration of 0.2 meter per second squared. If you go on the back page, you'll see what would be the acceleration of the cart if you push it east with a force of 25 Newton. Now I'm also going to use the equation with acceleration, so I'm going to do force divided by mass. Now I have the force of 25N, so that's going to be on the top, and I'm using the same mass as the first question because that's the given assumption. Suppose a loaded grocery cart has a mass of 50 kilograms. So I'm going to have kilograms on the bottom because that's a mass. And all I have to do is divide the two numbers. It gives you 0.5. So I would have to include meter per second squared as your answer. We will do more practices like this in the future. So if you're not so sure, we'll have more chances to do so. Okay. Newton's third law of motion talks about law of action and reaction. This may sound a little strange, especially you don't really think of motion into action and reaction term, but we will look into it and hopefully it will make sense if by the end of this video. So it says, for every reaction, there is an equal and opposite reaction. So if something is happening, let's say in 5 Newton, equal and opposite reaction will happen. So 5 Newton of opposite force will be exerted upon when something is happened. So for example, you pulling a rope on a sled where your friend is on. So let's say you guys are taking turns pulling each other on the sled, and it's your turn. What is going to be the action? Action is going to be you pulling on a rope because you're trying to pull your friend and make the sled go forward. Oftentimes we only think about the pulling action and say, okay, that's a force, and that's it. But however, we have the reaction, which is the rope pulling back every time you pull forward. So you may not really feel the resistance as much, but it's because you have the equal amount of force that you exert upon. And sometimes if you are stronger than your friend's weight or mass in this case, and your force is stronger, you may be able to move your friend forward. But just to look into the rope part, rope and your hand, you're going to have the same amount of reaction happening. Okay. Or for example, in terms of rocket propulsion, let's say you launch water rocket, or people launch different types of rockets into the atmosphere or out into space. When that happens, the action part is going to be the rocket forcing out gases backward. So that's an action. That's what's happening initially. And while that's happening, all these gases that are coming out from the back of the rocket is going to simultaneously push the rocket forward. And that's why the rocket is moving forward instead of going back with the rest of the gases. So we covered the 3 motion, again, action, reaction. We talked about acceleration and inertia. So these are different types of forces that are going to be affecting objects and how they move. You'll have a chance to work on these questions in class, and hopefully you'll be able to finish it. And I hope you review your notes so in the future when you are looking into these, you have an idea what is important, what are some things that you'll have to pay attention to, and so forth. And I also left plenty of spaces on the left side. So if you have any questions, make sure you write them down so we may be able to talk about it in class later on. Okay?